today we have a different speaker. If you don't mind, tell a little about yourself. How long have you been with EPAM?
I'm 1 year and 4 months here at IPA. And the different thing that we came as a group, so we are a group of data science here on the UK that we came from the same company all together. So we are like 11, 12 people that came from the same company.
Oh, good, good. If it's not a super secret, what's I'm really wondering what data scientists are doing on a daily basis.
We do a lot of things from like data part on the transformation. For example, we do a lot of ETL pipelines that extract, transform, and load. We also do a lot of analytics on the data side, so understanding the data, make sure that you have the right data, and also in the machine learning, so constructing like machine learning models from like computational vision, NLP, natural language processing, also like classification. So if you want to know if it's a cat or dog, you ask us, or we construct a model to do it. So that's our spectrum.
Okay, so well, that sounds really fantastic, to be honest. And so the main question, if you can make a computer to distinguish cats from dogs, well, how much time left for the humanity when machines will conquer us? So will it happen soon, or we should wait?
That's a question, or it's a matter of
Yes,
time?
it's a question.
It's a matter of time.
It's a matter of time.
Yeah.
Okay, good. So
Yeah.
within next till the end of this year, or at least we have opportunity to finish our current projects.
Yeah, for sure, for sure. Yeah, we have at least like 10 years for the Skynet.
Okay.
I don't know if the
For
young
this
one
kind.
will know about Skynet, right? So
Yes.
that's a whole joke.
Good. Well, I think that's a good start. Thank you very much thank you very much, everybody, for joining. Today we have a very crowded room at UK Engineering Community Session, and we have a fantastic presenter today who is a data scientist. I would rather say it's a senior data scientist. And so the stand is yours. Please start.
Okay, I'll share my screen again. See if there is no issue there. Again, we do a lot of machine learning models and etc. But sometimes when we try to share the screen, we fail. So can you see my screen?
It works.
Oh, lovely. So today I want to present to you guys a little bit of Julia. Again, it's a language it's going there for 10 years. It's getting a lot of traction during that years. And I had some colleagues and some people asking about it because I work with Julia for some time, and they want to understand more what's the fuss about it, why people are talking about this language, and they also understand more about the language words and what do we have like the historical language and why there is the new language and the new trends with a language like Julia. It's just introduction. For sure, you'll not be out of this meeting. You'll not be programming in Julia, but just to again to understanding what's the ecosystem that you have there, and we pass through like the introduction. What are the main things from Julia? What people use Julia? What attract people to this language? What's the environment for development? And we have some time for questions also, and I will show some coding in the end also. So let's see. Okay, so start with myself again. I'm Tuener Silva. That's how we pronounce my name. I'm a senior data science here at IPAM. I have PhD in optimization and machine learning. During the years, I work with several languages. I actually started on Pascal, but I just did one programming in Pascal, and then we'll go through C, Java, C++, Python, and the last one is Julia. There are some other small language like MATLAB, Julua, and other ones that I work for a small period of time. But one thing that I want to tell you guys, that's how I get closer to Julia and why also. So, and my story, I think you understand why I use Julia. So I was almost in the end of my PhD. It was like 2014. We already knew, me and a group of students on the same department already knew about Julia. And I was programming my whole PhD using C++, doing my thesis, and Python was out of the reach because it was quite slow. We need performance. We are publishing a paper. We need to compete with other laboratories that are doing the same thing. So we use C++. It's a nice language to have it. It's quite good in performance side, but there was a lot of issues with integration. There was a lot of issues with different libraries. One special thing that I remember is that C++ didn't start with a good implementation of vectors, and each library used different vectors. So I have my linear algebra library that has a specific type of vector. I have my optimization library that has another vector. I have C++ vector that now then we have like good implementation. And it was a nightmare to go in with three different kind of vectors on the same language. And there is, for example, integration with MATLAB that was quite horrible. And so before, like 3 months before I finished my PhD, a little bit more, my co-advisor asked me that if I knew like Julia language, and he's come to me and say, I think this will solve all your problems. How about writing everything in Julia? And it was like 3-4 months to defend my PhD. And I said, no way, no way I will go do something like crazy like that. I was not sleeping that much that period, and I said, no, that's not a good idea. Let's postpone a bit, and I will finish it with C++. I know that's a nightmare the way they were now, but I will not rewrite everything. So after that, I had a little bit more time. I finished my PhD. This is done, and I still was very skeptical with Julia. Again, I tried several different languages during the years, and C++ was the chosen one for this type of research. So I was convincing by my co-advisor that did like his initial sketch for the same procedure that the same model that we are constructing for C++. And this guy is not coming from like computational background. And I was quite surprised that he was able to do something like that. And I took this, and like in 2 weeks, 3 weeks, we have like our initial version. And I was hoping to come back to him and say, oh, that's 10 times lower than my code in C++ that I was developing for like years, and it was something like 1.2. So 20% more in performance for a thing that we developed like in a couple of weeks. And we are talking about the initial code on Julia. I did any performance enhancement there. So that's when something clicked in my mind. I said, okay, we have something here. This language could be something that I will be working with and I will using for my applications, my research, and etc. So after, and you cut this, and after like a period of time, 1 year later, I was using Julia for everything. And I used Julia for almost like 5 years as my main language. And today, that's the main story here. I will tell you guys how I use Julia, why I use Julia, why people use Julia, what's my story on using Julia, what are the main things that you have there. That's the narrative of today. So the introduction, again, I just want to give you like an overview of the language, what's the historical of the language, in order to you guys to understand what's the next step, why Julia is the next step on my vision. So we start in the 50s. Again, we have like low-level language that's were quite difficult to develop anything on it. It take a long time to do that. It's one step further than the puncture cards that we have before that, but still they are quite difficult to use it. It's difficult to develop a huge application using that. We are on the beginning phases of computation also. So in the 50s, we start to having the high-level language, one of those like Fortran, one famous one, and we start to become far away from assembly, so from the machine level language that we had before. with that, we also get like MATLAB, C++. Probably you guys don't know that MATLAB is that old. If you know MATLAB, I thought, well, it was much younger than that. I was not thinking about 78. So we start to have this more high-level language that we can develop more big projects, doing more things, more people getting to this programming. But in the 90s, that we have like the popularization of programming language. So we have Python, Lua, that's a language that's developed for the same department that I study and I did my PhD, R, Java. So we start to have this language that a lot of people are using, get more traction. You see even like kids programming Python, for example, and you start to have more and more spread use of programming language. And after like 2010, 2009, we start to have specific language trying to solve a problem that we have with dynamic language, especially coming from Python. Are also they have in MATLAB, you sometimes have to choose, or you have like a very high level language that a kid can develop, or you have performance. So you have to choose one. You cannot have both. And that's the beginning of like Go, Rust, Julia, language that has the performance, but also they are very high level. So in the evolution of the programming, you have something like this. This is like the initial Fortran. Okay, so if you saw Fortran before, you probably not saw this version. This is the old version, the 1.0, and you have something like this that's quite difficult to understand. It's quite verborradic. You have a lot of things here, and you go all the way to like Julia or Go and even like Python with much more simple syntax and something that's very easy to understand, and you don't have to worry about too much about typing and things like that. So it's just an example that the path that we went through to the 50 years that pass. So what's the main thing that we have about Julia? Again, Julia starts with like utopia, and it's good that we have this saying here that they begin with "we agreed, we want more," because you can see that's the statements that they have that Julia. That's an open source that they want like speed of C, dynamism of Ruby, macro like Lisp, familiar mathematical notation like MATLAB, general programming as Python, easy as R for a statistic, per string processing, linear algebra like MATLAB. And in the end, they say, oh, we still want to be like something that's dirty simple to learn, and you also like keep the most serious hacker happy. And we want to be interactive, and we want to it compile it. And the first time that I saw this in 2014, me and a group of students on the university started to call like this the God language, because they want everything. They want to have the best thing on all the language. They want to be also quick with this, and they want to aggregate this in a new language. And it's almost like again an utopia, and it's too difficult to imagine that someone can reach at that level. But you see also what kind of people that was constructing Julia. Those guys come from different language. They pass through, like me, they pass through different language during their years. They know, oh, I like a lot this, for example, macro from Lisp, because I can do incredible things with this. I know I like a lot the string process from Perl. So they are very specific, and those guys use those language for a period of time. So they are seeing this new language that aggregate all those good things, and that's a good thing, because when you want to construct a new language, you want this person to have all this knowledge from the other language, and it's quite good group of guys in order to create a new one. So, but we again we have this like saying that, oh, again, you have to choose. Sometimes language choose to focus on one side or another, but Julia want to get everything together, and they want to do all this as good as the other language. So it's quite a big statement for the language. But before I start to answer this, if they reach or not, I want to guys to understand what is Julia. What's the Julia bring to the table and how it does that. So Julia is a dynamic and flexible language. It starts on the academia side. We have a lot of traction in the, especially like in the 2014, 2015. because of of some things that Julia resolved for us, like the two language problem that I will talk later. Because it has performance you can use for statistical, like R. There are several people that replace Python, R, and MATLAB for Julia because of the good things that can bring to the table. Julia provides an easy way to express in high-level numerical computing, the same way that language such are MATLAB and Python, but also you can do like general programming. So, for example, you see R a lot, people using in the university, and sometimes our data science community use a lot, but you don't see that much production level coding using R. It's sometimes it's quite difficult to construct a pipeline like using R for CI/CD, etc. The tools are not there, so they want to have like a general purpose language. And to achieve all this, they will build on the knowledge from the other language. They will use that knowledge, and they will. You see a lot of copying doing that, and a lot of people think that, oh, I also have this on Ruby, on Lua, and etc. But and they will say, oh, just copy from the other language. But I don't think that's a bad thing. Picking up the best thing from each one of the language and putting together, that's astonishing for me. I want to have something like this. As a user, for me, it's fine to copy. I don't have any issues with that. And they don't like hide this. It's in plain sight that they are copying things, especially the good things about the language. So what are the top regions that people come to use Julia? So that's my vision again, but I still think it's very easy to learn. I teach Julia for a while, especially if you're coming from Python. If you know Python, to jump from Python to Julia, I think it's very easy. There is some special things also, Julia, that we don't have object orientation in Julia, so it's make things even easier from my point of view to begin in this new language. It's fast, so I also have this several occasions, and sometimes I would have like two different language, because if I want to prototype, I want to do something quick, and I want to use Python, for example. I don't want to prototype things on C++ or even Java. It will take some time in order to do something like that. So if I want to do something quick, I use Python. But sometimes you need a little bit of more performance, especially on the computation side. If you are like publishing a paper, or if there is something that's quite heavy on the computational side, sometimes people will go all the way to Fortran in order to have, or C in order to have performance like that. But C++ normally have good performance. So I would have two language on on daily basis. One for prototype like Python, another for C++. With Julia, you start with Julia and you finish with Julia. You don't have two language problem because the performance is good there. So you don't have to start to develop in a very high level language and then rewrite everything in C++. You start with Julia, and there is like a level of coding on Julia. So you can do coding very quick, but sometimes if you want to like have more performance, you can like tweak some things in order to have more performance there. But the good thing is that you start on the same language. You don't have to rewrite everything. You just have to tweak some things in order to have more performance. And normally the initial code version, the initial code like you saw before, it's quite good. You not have something like 10 times more slow than C++. So the initial code is also very good. It's free, open source. For me, it's a quite important thing because you can see coding, you can help develop the language, you can go and create an issue on GitHub and ask the community to help. It's a very good thing, and most of the language have that. But if you think about MATLAB, for example, you don't have something like that. And I had the issues before with MATLAB to knowing that maybe there is something wrong with this code, but I don't have the code. I cannot. I can use support, but I was a student, so it's quite difficult to go in that path. So I want to like have people verifying this code. A lot of everyone can see the code, check, and do things with it. Open an issue. Things are much more quick in a language like that than it was closed source one. It has high level integration, and that's astonish good. And those guys, again, if you come back and see what we're talking about, that's people that's coming from a different language, and they know that the transition is quite painful. If you have all your libraries on C++, if you have to go to Python, it's a nightmare. That's why you see that Python was like in the 90s before it was invented, and the traction of Python just reached in the, don't know, 2010, 2008, you just start to see more and more Python. So it takes time in order to people to transition to the language because you have already packaged in other language. So one thing that I never saw in any other language that I used before, it's the high integration that they have with some language, especially like C, Python, Fortran, also R and MATLAB. It's very high level, and you can import things, and sometimes we don't even know that you're using Python, for example. The other thing is the package. So again, we still can use like package from another language, but the best thing is to have your package on Julia. It will be easy to install. It's the same language, so there is a difference between using a package in Python in Julia than using a Julia package for sure. So you have like now more than 7,000 packages on Julia. When I started, it was like 1,000 or something like this. And you start to see a lot of packages that you don't have anywhere else. So for example, the main package that I use for optimization, you don't have anywhere else. So we start to have building this community, you start to have more people with the language. So with this, we have even more package. So about the performance, this is a benchmark that Julia likes to show about the performance between the language. When I started to use Julia, this was quite different. So we didn't have something like JIT for just-in-time compiler for Lua. Rust and Go was quite higher than it was today. This is like open source benchmark. So if you think you can do a better code, you can submit there. The thing is that it's comparing everything with C. So we have this line here, it's like 1. And you see that those guys are like quite scientific. They don't say like 1, they say 10, 11, 10 elevate to 0 instead of saying 1. But this is like the 1. And so it's the code that you have with C, and you're comparing everything with C. So as close as you get to this line, it's better. You are close to the C that they think they're the main performance language. As you go further, you have like 10 times, 100, 1,000, and 10,000. So as you go further from this, things start to get ugly. So in the initial, you see Julia, that's quite close here. You see that maybe you can have like 3 times, 4 times the performance of C. You have Lua that when they develop the JIT, and that's one of the secrets that you have with Julia, that's the just-in-time compiler that's doing in the things on the execution time in order to enhance your code, in order to use them almost like a strong typed language in order to enhance your code. With this, Lua will become much more quick, and it's quite good also language. Rust also the same thing, using sometimes the same tricks as Julia. Go also doing similar things. So you see that those are the language that has close to C performance. As Fortran also has good performance. Sometimes it depends on your vector, the way that you construct your vector from having better performance from Fortran or C. They sometimes compete with the best performance. Java, you start to see that you have sometimes 10 times the difference. And if you think about small things that, if I'm taking like seconds, 10 times, not that much. But for example, sometimes we run like computational machine learning models for like days. So you're saying that you could have 1 day or like 10 days in order to have your model. So that's start to become like quite different. JavaScript also spreading all over, and you start to get in the middle of the hundreds there. MATLAB, incredible thing, a very, very, very old language, and still the performance is quite horrible. If you use MATLAB before, you know that there is like some tricks that, oh, you cannot use fors. And I remember people say, what? I have to program without fors? Yes, you have to do it. Do everything matricial, use linear algebra as you never used before in your life. Pick it up like it's quite fun in the end to do something like that. But for programming, for general purpose, it's quite difficult sometimes to do everything using matrix and do like big expression using matrix. Sometimes you do one mistake and you don't know what's the problem there, and you start to see like quite big performance issues. So hundreds of times that you have with C. Mathematica, that's also a language for scientific things and etc. Also, you see something like that. Python also, you can have like something that's hundreds of times lower than C. R, it's even worse. You start to get to hundreds of times. And Octave, it's an open source alternative to MATLAB. It's even worse than that. So we start to see that you have a good performance here on a group of the language, and others are trying maybe to catch up sometime in the future, but they are quite far away. And remember that this is like using the language, because sometimes you can go to Python, for example, and don't use like Python at all. So when you call like NumPy, you're not using Python, you're using C. So that will be very close to C. But here is using the language. So on Julia, they want to have the language having a good performance. You don't have to need to have to use like a library in order to have performance. This is using Julia. So what are the other advantages? And there's some of those. There are others, but the best thing that you can see that they gather the best from other language. So there is a clear advantage of being Julia now, and Fortran that was like more than 50 years later. Julia saw a lot of different language going and even die through the years. So leveraging on that knowledge, it's quite a good thing that you can do it. It's designed for parallelism and cloud computing, so you see a lot of things that it's very easy to parallelize. Even in your for example, you have macros for that, and it's quite easy. We have terminal, and people sometimes are afraid of terminal, but you can see that, for example, terminal with Python, it's 50 years old. We don't see much difference from the old terminal that we have like in 9080 or something like this from the terminal that we have today in Python. Terminal in Julia, it's like the Python terminal with steroids. For example, you can add packages on the terminal. You can easily get help. You can change your terminal. You can do like even constructing environment like you do like with using pip using your terminal. So it's quite strong terminal and it's quite powerful, and that's a good thing because you can have this tool in order to help you. Memory manage for me, it's a good thing. I'm gonna be honest. I don't like that I have to worry about manage my memory, especially if C++ that you have all this like memory leakage problem that you had before, and it's a nightmare to find it and debug it. So for me, it's a good thing to. Some people don't like garbage collector. I like it. So what's the timeline of the language? So you saw that statement from the group, but that statement was in 2012. But they begin to develop this language a little bit earlier than that. So the idea is born in like 2009, and it took a while in order to them to make public this, that they were developed this language that they want all of that. Probably because of the statement that was quite bold. So it took a while to them to officialize this. In the first version of Julia, it was in 2012, and that's the date that it was born. It's almost the same group with one or two people more, Jeff, Stefan, Vero, and Alan. So they construct the language together. The first annual conference with Julia, it was in 2014, and every year now they have this conference. Julia company, that's a company that's it's not they not own the code, the Julia language. They have like side things that help you with ecosystem around the language. Sometimes the way that you deploy the solution, similar to Jupyter notebooks, also how to host those using Julia. So there is things around it that they have this company in order to sell those. The 1.0 version it was just released in 2018, and everyone was anxious about this. I was one. You later understand why. And in 2022, we have like 10 years of Julia. So it's the 10th year anniversary. So this is the path from Julia. What's my path? What's my interaction with Julia? So you saw the initial phase that I learned about the language. I started using in 2014. First, because also we have like strong optimization package there. It was called Jump. It's called Jump. Sorry, it didn't change the name. I use because it solved my two-language problem. It is a high-level language with performance. I convinced a lot of people around me to use it because of that also. And Jump also enabled me to construct model quite easily. So it was quite good for my PhD. Although I didn't use in the PhD I used before, but for my research as a general thing. No messy stacks on 2015. I started on like a new laboratory back then, and I was like defining the stack for this laboratory. I was more like CTO for a small laboratory, and they have like quite messy stack. They have like MATLAB, VBA, mathematical modeling language, and it was a nightmare. And we still were in the beginning phases of Julia. The version was like 0.4, 3, I think. And I was betting that this language will like change the way that this laboratory is developing software. So I get rid of all the mess. Don't go through Python. Don't go use MATLAB. Don't use VBA. Don't use the other mathematical language. Use just Julia. And oh, but what's the problem with the interface? We need to do like front end, back end. Julia doesn't have in that time. Today we have it, but back then we didn't have. Or you hire a group to do that in Python, and we use both language, but different groups, or hire a third-party company to do the back end and front end. And that's what they do back then, and it worked quite well. We start to really develop astonished product with this same stack. And we start, but the problem is that this language was on version 0.4. It's still beta. So I have to make some strong promise back then. That in some projects I even like promised that I will rewrite everything in C++ if there is some issues, but everything worked out. In 2017, I started teaching Julia for multiple universities. Even the clients that we have with this laboratory, it started to sparking everywhere. And people start to have the interest in other learning the language. So I start teaching them in the university and also for companies. And you see a lot of people that you didn't know that was using Julia, that they were using Julia. In 2018, on this laboratory, they delivered like a big project with Julia. And I think it was like clear that this company has to use Julia and don't have to use any other language anymore. It was quite successful. It was a quite difficult project. For example, we need to integrate some things with Fortran coding. And we did this in very good fashion using like the integration from Julia. We need to connect database. Back then, especially in like 2016, we didn't have a good connection with the database in Julia. And we worry about this. We use connection from Python. It was quite easy to use. So everything that we start to have issues, we solve it, and it was very good. This company was using like GitLab back then. I started using GitLab for them. We have our CI/CD. We have your proper develop. So this transformed the way that this company was developing software. And we did a very good delivery for that company, and they still doing the same business with this company nowadays. And they still use the same stack that I create there. In 2019, I was always close to this like Jump package that we have for optimization, Julia. So I went to a conference there in Chile and interact with the guys that was almost like my hero. They helped me a lot, so it was a good interaction there. And during the years, especially this phase that I started using from 2015 until 2020, I used almost like just Julia. I have like 7 research paper. All the community around, especially in the optimization, are using a lot of Julia. And you see all other communities using a lot. They quite heavy users of Julia. I delivered 6 different projects using Julia using the same LAMP stack that that I talk about here. So it was quite a successful story for me and LAMPS. That's the laboratory that was working there. So okay, now you understand a little bit of Julia. Let's go to Julia's users. So you understand about me. I'm one of the Julia's users, but there is a big community there. There is a lot of people that use. So on the company side, I have this, and still like this is coming from Julia Computing, but I don't. Again, this guy is not like a very good sales people, but I know that's a lot of companies that's not here. So this is like 2016 image that we have back then. A lot of the companies that I develop software and I know that they're using, for example, in Brazil, it's not here. I know that company here in UK that's it's not here. So it gives you overview that like the main companies they are at have. And we have like positions and that's was quite incredible for me to see. If you go now and look at LinkedIn, you see a lot of people talking about Julia in several different positions and positions that sometimes they require you to know Julia. And that was for me like a new thing. But Julia is spread on thousands of this industry. They are using all over the place. A good thing also are the use case that you can go on Julia's site and see. In the beginning was like 5, 6 different use cases. Now it's more than 50 use case, from bankage to mortgage to transportation, energy, and even like I have a friend that developed like a software for dairy farming. So it's even an optimization project for this. So there is even for if you want to like milk your cows in a proper way, using derivatives for that. There is a project there that use Julia. So all of this using Julia. One that I want to cite in here that was quite good to see on the site, and I think it's quite old already, but it was this like I think it was Celeste, the name of this. It was like parallel supercomputing for astronomy. They have a huge amount of data, and they have to do analysis on this, and we are talking about millions, hundreds of millions astronomical objects, and they want to achieve like something quick, and they did this using like Julia, and they achieved they achieved like 14.6 minutes using that Julia. And it's you're talking about a huge amount of computation, and they put here that in just one thread, I don't know exactly, they don't say what language they used before, but just one thread, they have an improvement of 1,000 using Julia. So that's quite astonishing also. Community, what you have around, there is even I'm from like computational science and data science, but there is even communities that was using Julia before us. So BioJulia was a very old one that people started using Julia from biologic frameworks, and they were already there when I started using Julia. Flux machine learning, so we have some machine learning models. Even here from the UK, also the Alan Turing Institute is constructing a whole new package for machine learning in Julia. And there is other communities like for differential equation, dynamics, physics, math. You see optimization here. You see quantum computing. You see a lot of different communities. Right now we have more like than hundreds of communities here with different purpose. But what's the programming environment? What we have in order to do our coding? So in the initial phases, we use a lot of Atom with a plugin called Juno to develop on Julia. Nowadays, almost everyone going to like Visual Studio Code with some extension, and it's working quite well. You can use Jupyter. I don't know if you guys knew, but as a curiosity, Jupyter, and I don't know if everyone knows here what Jupyter. From data science, we know a lot about Jupyter, but Jupyter is like a notebook that you can do like coding and also putting like information, documentation about the coding. So I will show in the end a little bit of Jupyter, but it's quite important too, especially for data science. And the Ju on the initial of Jupyter, it's because of Julia. So Jupyter is Jupyter, it's Julia, Python, and R. So it was constructing, looking for those three languages. There is JetBrains, you can use that. If you're old people or if you like crazy ones, you can use Vings or Emacs. I have a history of Ving, but I don't use anymore. Sublime Text, Revise, and we also have like a solution that was developing Julia to Julia, and it's almost like a twin from Jupyter. There is some difference between the Jupyter and Pluto, but Pluto is an interactive dashboard that you can construct there. It's very similar to Jupyter, but it has some difference there. So what's the visualization that you normally have with Julia? It's something like this. You probably is familiar with this, but it's very common if you saw MATLAB, for example. It's something that I think it was initial constructed in MATLAB, that you have like a project, you have your code, you have your terminal back here with Julia that you use in order to query things, in order to understand functions, in order to interact with the language without having to code, messing your code on top. It's quite a common thing to have, and it's helped me a lot. I like to see something like that on other language. Python people, I don't think Python people use that many terminal. You can have plots here in order to investigate something. So that's coming from like MATLAB. That's you can also see your plots together with the IDE. You can have your documentation here, debugger, and everything else around. You have the workspace, the variable in order to debug things. You have similar thing with Visual Studio Code. That was Atom. This is Visual Studio Code. They always try to have those like same panels there. And that's quite common way in order to interact with the language. Some links that I want to give you guys, and just stop a bit for questions. I still want to show you some code, and I have this code from Linus that say talks chip, show me some code, and I want you guys to see some code, but I just want to stop a bit here and see if you guys have questions, and we can like have 5 minutes for questions, or if not, I can proceed. So if you have any questions, any doubts that you want to see here or want to ask, just feel free to do it. And that I will just change my terminal here.
By the way, if you may also put your questions into the chat, I can read them if you want.
Yeah, that's really good because I don't think I can reach my chat anymore.
No worries, there are no questions in the chat at the moment. But everything's...
I don't think we can actually reach chat if we're looking in Teams.
Yeah. So we have a question from Alexandra Halavati. I think I managed to pronounce your name correctly. The question is, can you use Julia for test automation? Does it make sense at all?
For what? Test information?
For test automation.
Yes. So for example, in that case, I don't know what level you're talking about test automation, but on that case, we use like CI/CD. So you have unit tests in order to do that. If you talk about Selenium and things like on a high level on the interface, that I don't know. I don't actually know if you can do something like that. But if you're talking about unit tests, the language begins with unit tests. So if you go in any package online, you see a lot of unit tests done in Julia, and you see all the automation done. So for example, you can go to jump.jl, and you're gonna see all the
by the way, you're sharing your command prompt out? No.
I was just like typing here, so you can see all the testing done here, and you can see all the testing for unit tests done here on this folder. So the unit tests and covers, you see a lot of on those packages. So everything here, and probably if you want to know more about the language, there's some package like Jump or any other package from Julia. It's good to see what's like a big project on Julia, and you always have like documentation here and things like that. Don't have the covers here. Oh, there is the CI here. So I have like the whole automation for CI. Okay. If that answer, let's go to the next one. Yeah, you can raise your hand and ask the question for sure.
Yeah, there is a hand. So Mikita, please unmute yourself and ask your question. You're very welcome.
Yeah, thank you very much. I have a quick question. So usually nowadays we call some external C functions like in PyTorch, yeah, when you doing some deep learning, etc. So what's the point then using Julia if it's written in C anyway? Like it will be fast anyway. So what's the point? Could you please clarify this?
If you're just using like a framework, and that's the only interaction that you have with the language, again, that will be the same thing. But for me, for example, we have this huge project that we are going all the way to do like Monte Carlo simulations in Julia, to interact with optimization in Julia, to do like time series in Julia, and we are doing a lot of code ourselves. So it's not something that you can pick it up a package and do it. So, and we are also using a lot of package. So the thing will be that if you just have Python, for example, the part that you're using the package will be quick. But when you start to use your own code, it will be slow. So if your code, it's like a main thing on the main model that we're developing, that will be a nightmare because, and that was my case. My code interacted a lot with the libraries. So it's something that we are doing, like solving thousands of optimization problems every second. So and my code is doing part of this. In that case, if I have like slow code, it will be like, instead of waiting 1 day to finish my simulations, it will be like 3 weeks. So it was almost impossible to use something like Python in that situation. So if you're just using like PyTorch, I have my code, I just use PyTorch, for sure it will be the same thing of using like Flux or a machine learning model in Julia, and the performance will be quite close. And it will not have like difference in performance in that case.
Yeah, thank you very much. Just a quick follow-up. I know that all the packages like written in just Julia, yeah, like Flux, etc. So, and you can actually debug this code, yeah, when you developing it, yeah.
Yeah, exactly. So that's a good thing about also the language. It's one of the language that's it's writing in itself. So, for example, you see PyTorch. You have to that the person that developed PyTorch has to know not Python, a lot of C in order to develop PyTorch. In Julia, people that develop Flux, they develop in Julia, not on C. So you can use their own language in order to construct your package. You don't have to have another language in order to do the package, and that's a quite good thing. Also, that's important.
Yeah, thank you very much.
Anyone? Oh, have one more.
Yeah, we have another hand. So Anatoly, I see your hand.
Yeah, so it's like a follow-up. So I've used Julia myself, not in professional work, but in personal things, and I think we've talked before. Would it be fair to say that Julia is well suited to computational, like very highly computational things that require a lot of customization? So as you mentioned, like with PyTorch, if something's implemented in PyTorch, you can use it obviously through Python, and Python is very good for like pseudocode and like controlling like control flow sort of things. But it's very bad if you have to have like callbacks into your Python code,
Right.
and so on.
And that's also lead to one or another thing. Imagine the other side. Imagine if you have PyTorch in Julia instead of in Python. Why did you use Python? You never use Python because you're just using Python because of the library. So if the library was writing in Julia, you just use Julia. So there is other things to come for Julia than the library rounds. You have like the performance, and if you don't have to do like MATLAB, for example, again, I told you guys that you have to do everything like linear algebra in MATLAB, because that way you're going to use the library that was actually written in C or C++. And you're not using MATLAB at all. You're just like calling functions from C and C++ because the language MATLAB is quite slow. So that way that when you're using Julia, you don't have this overhead. So if you have PyTorch in Julia, you just use Julia. You don't have any reason at all to use Python after that.
All right. Now for my question, it's regarding a lot of use cases. Like Julia is working well with big data, apparently, right? But from like looking around, it's very difficult to see something that isn't like custom written. Like what is the equivalent of, for example, like Spark for Julia?
I actually don't know that answer. I will say that the same thing that I say to the students sometimes, because students have all kind of questions. I don't know that one. I will search for it. So next day of the course, I will tell the answer, because I don't know. The big data part, I know that there was some initial ones in like 2015, but I don't know if they still alive. So I don't know.
Yeah, from what I saw, there was JuliaDB, which was this out of core stuff, but it's now defunct. But there's also
Yeah.
Dagger. There's also Dagger, which is like a general purpose computing distributed thing, and also just bindings for Spark. That's all they've been able to find for now.
Yeah, I know JuliaDB, and it was like a PD that was like discontinued, but the new ones I don't know. Anything else, guys?
I have a question for Thuner.
Yeah.
Can you hear me?
Yes, yes.
Yeah, so in terms of like comparing the implementation of Python, you know, in scikit-learn, TensorFlow, etc., how does it stack up with Julia? Like you say, are you using, for example, Julia to do, you know, NLP? What are your use cases, and how does it stack up with the Python implementation? Not in terms of performance, but in terms of ease of use and yeah, ease of use essentially, and also expressivity.
It's I will show some examples here. It's like very easy to use, but again, as the other people talk about, sometimes you use Python. I use more Python because of the libraries. So
Yeah.
if you have your library there and you want to use like PyTorch, there is no reason to go. And it was just calling things from like the library. There is no reason to go all the way to Julia and make Julia call PyTorch that's in Python. You go directly to Python.
So
But sorry.
so this so the ecosystem is not yet mature, but eventually may become sort of. What's your prediction, sort of?
I would say something like that. But when we are, for example, in that laboratory, when we are constructing something, we were afraid, for example, of using Python, because if we start a project, imagine like 2-year project, and we start in Python, and our coding is they need performance in the end, we have to rewrite everything. And when we start with Julia, it was like almost like a relief that we don't know that we know that we don't have any issues with performance in the future, and that was quite heavy computation on side. So, and if we need to use any Python code, any Python framework, it was easy. And it's just like using directly the Python code. And again, you're calling C, and the connection is not that the overhead of the connection is not that high. So it was easy to do something like that. So we know that even though we not have all the packages in Julia, we could use any package that we want, that you need, almost any, and even more than Python, because for example, there is things that you can use in MATLAB. We have to connect with Fortran code there, and we connected. It was easy. So it was quite a good transition for this laboratory. So nowadays, I use a lot of much more Python because of the constraints of the clients. So clients want to have Python, not because ourselves. So when I have the freedom to choose, I use Julia for sure.
Yeah. Okay. Thank you.
And we have one question in the
Just
yeah,
very quick. I suppose it's very quick. Did you have a chance to work with application in Julia over some cloud provider? Do you know if there are some cloud provider that provide just a platform for Julia?
No, back then, no, we didn't have any application cloud on that period. I used before. I know that there is support. I was after that, but I never go all the way to production with Julia on cloud.
Okay, just a curiosity. Thank you very much.
Last one question from the chat, and next we will proceed if you don't mind. We have a question from Malik. How good is Julia in building web applications in terms of security?
I don't know that one.
Good.
That's also one that I will probably search about. I also have to back here. Otherwise, I don't know if we have like strict deadline, Alexander, because I have.
No, we have time.
Okay. So let me just again, I will show you here some things about the language. Also showing code sometimes is even easier to understand than talking about it. So I want to show some things here. So the first thing, this is terminal. Again, people don't like this. I don't like because of the round thing. This prompt from Windows is quite bad, but it's the thing that I have here. So here's the terminal of Julia. You see that even I have colors. You see Python terminal without any colors at all. So the first big thing is that you have colors. And you can like do anything that you do probably in Python or anything else. Probably you guys, my screen is a little bit cut there. I will put just a bit there. I think because of the red line, probably you guys seeing the whole screen. And you for example, this is dynamic type language, so you have the type of B, and you have that's a float. Okay, so you have like the part of the linear algebra libraries. If you want to have like random vectors, here it's a random vector. You don't have to import nothing, it's here. If you want, for example, to have a vector element-wise multiplication or element-wise elevation of this vector, you can do it. So just use like dot on the initial of this, and it will elevate every element of this. And you know what you're doing. Sometimes in Python you can do something like that and evolve the dot and it will work because Python it's adapting. But and this is also like sometimes bad for new people because they don't understand what's happening. One thing that I want to show, and again, that's the terminal. You can also do something like that. If you put like exclamation point, the terminal change and you can help. And you, for example, can call print alien, and it will have the documentation. You can do something like that in Python, but again, it's a little bit one step better that you change your terminal. You have the change on the console side, and things appear more like easy to the eye, and that's a good thing. One thing that I want to show you guys, it's, for example, if I want to use R on my Python code, on my Julia code, sorry, I just use this package call like R call. And for example, now I can start using R. And if I use the $sign, I transform this terminal now that was Julia. Now it's a R terminal. And I can come here and do anything that I will do on. And I hate this thing here, this arrow. And C, for example, oh, I think I forgot to define C. Yeah, let me define C here, equal 10 on Julia. Now I'll go back to R and I will do the same thing that I did before. So I'm using now this variable C that was defined on Julia and using on R. Oh no, I'm using it's not like that. Oh, probably have to import something. Oh, R norm. C. Oh, okay. So now we have a vector here. I forgot about the $. So this is a variable that I was using on that I was having on Julia. Now I'm using inside of R. I can change my terminal. I can ask the value for this variable that was constructed on Julia. So there is this like high level integration, and they are not afraid to like transform your terminal from Julia to R. You can do something like that. It's the same thing for Python. So you have this high-level integration that you can choose to use Julia. You can choose to use R package, Python package, MATLAB package, and it will work fine. Another thing that you have here, we have the package manager. Yeah, I don't have to use pip. I don't have to use to go to massive things about Conda, Anaconda, and things like this. The package manager is together with the language. So you have here the package manager. If you put like close brace this thing here, it will like transform this terminal to a package manager. And with that, you can have a bunch of different things. So for example, I can ask help for this, and it will give me all the commands that have with the package manager. So I can say the status of my package manager here, and it will tell all my libraries that it's installed on this environment. And you can have multiple environments, and this is all coming from the language. It's not something external, it's from the language. You can have your requirements as you're having on the requirements pip and everything this, and everyone will use the same because it's coming from the language. And we can, for example, add a package here. So I will add one package here and you see how it's done. So like that, I add a package for opting. Sometimes it takes a little bit time because it's compiling the package for my machine. So sometimes you see a little bit of waiting, and then let me see if my machine is ready for computation. Yes. So sometimes you see some loading in the end because it's compiling. So it's fetching, and it will probably compile for this machine. Sometimes it will have already the compiled version. So you can add the package. You can do multiple things here. You can have multiple environments. You can have your environment for your package, and everything using the terminal, everything using the language. And you don't have to worry about your partner using the same person that it's programming with you using Conda, or I'm using pip and you're using Conda. Oh, Conda will explode and everything like this, because everyone using the same package manager. As soon as everyone is using the same environment also. So that helps a lot with interaction with different teams and etc. So this is like the pre-compiling process. So that's also part of the performance of Julia. So it's pre-compiling this package for my machine, for my use here. So that's also make things much more quick than if it was like a generic code. But sometimes it take a little bit of time. So I add a package. If you go back and status, I go back to see status, you see Optim is there, you see the version that I have here, so install. If I do rm Optim, I'm removing this package. If you go back to status, not there anymore. Everything you do it here. If you want to update everything, and I will not do it because it will take some time, you can go here and update, and it will update all the packages that you have. So that's very good. And again, this is like the main environment that you have. But you can have others environment. You can activate one environment and use similar to use like when you use like environment with Python. So using, I will just show a little bit quick. So as I told you, Jupyter also come from Julia. So we can start like Jupyter lab here from Julia. And it sometimes people will call like iJulia instead of Jupyter because of that, because it's just like an extension of Jupyter Lab using like a kernel of Julia. So here you have the notebook. If you don't know about this, you can have like a documentation. You can have markdown here, equations. That's a good thing for me, especially because normally you have like the model, the mathematical model to go together with the code. I use a lot as a data science in order to have the initial notebook for people in order to understand my coding. You can do something like this. You can run the cells, like with Shift or Enter, you can run the cells. Just you guys to see this is like Markdown. So you can have all the whistle vessels from Markdown. Like we saw before, you can do like element-wise operation. You can ask help here. You can do this kind of thing, and it will like even good things that I like to see on more on the other language also. Give me examples. When I ask for help, give me examples, please. You can also have like strong LaTeX coding here. So this is from my PhD. I don't know, probably old version of my model of my PhD. You can add package for here. You can do plots. So you see the plots here. And you can also like use PyCall. So use Python code here. Even though we are on Julia kernel, you can use Python code because of Julia. Again, the same way that you saw there on the terminal, you can have it here. So for example, I'm using PyCall. I don't know if it's too small. Probably zoom, it will be better. So I'm import math from Python here. So those two steps here, I'm using this library PyCall, importing math, using sign for math, and also using Py from math, and giving the example here. So you see that this is something very incredible for me. I don't know if there is any other language that has this high level of integration, that you almost don't see that you're using Python. You can have like using SciPy, for example, import the SciPy there, and using like, for example, Newton function from SciPy. You can have there is other type of integration. So for example, if you have like a whole script of Python and you want to attach this direct to your code, you can do something like that. And you have the answer here. And the same thing that you saw with R, you can use like strings in order to interact with R, and just put R on front of the string. So just for fun, I will do some performance comparison here. So we can use Python here. So I will use a Python code that's inside Julia in order to do some comparison between like this is like summing random numbers, if I'm not wrong. And I will use like PyCall in order to do the Python code, and also and here has the Julia code. And you see that I did nothing here. There is a lot of things that you can do in order to enhance this code. I just did like initial version of the code, nothing fancy. And just elapse the time that for that. So you can see here that we have like 0.003, I think it's milliseconds, this one, in order to run the Julia code and the Python code. And I didn't cheat. I didn't like time the Python code at the Julia level. I timed it on the Python level. So I'm using a fair game here, and it's like more than 10 times slow, and just like a simple code. So again, that's the thing that we have all the time. If you want to use a library, that's fine. But when you construct your own code in Python, it will be slow. So it was here. It's like, so it's 19 times. It will fluctuate. I'm not doing like fair comparison. Okay, just to you guys to see like a simple code that's like just summing on Python, and a simple code like just summing random numbers in Julia. So, but let's go one step further and let's try more heavy loopings there. So I'm interacting with this code and having more and more random numbers. So there's two things that you're doing here. Actually getting each interaction, getting the random numbers and sum them all together. And I'm going like 10 to 0 to 1 to until like 8 in order to have this plot here. So you see, for example, there is a huge spike. I don't know what's that, but it's not supposed to be that big. So you see something like 25, probably. If I have to run this like 189. What's that? But you see like 27 times more slow than Julia code, and that's the important thing here. If you need performance, you go for Julia. And when I use Julia, other than like constraints from the clients, there is no reason to use like Python on that laboratory that I talked with guys before, because anything that we need from Python, we can use it. But if you start a project in Python, it will be a nightmare to use like Julia code. So every time we start on Julia, and we use any library that we want in all the language that we have, like MATLAB, R, Fortran, C. All this integration make more easy. I have also like a Pluto notebook, but I will not have time to show. We are a little bit late on that. I will just show you that there is this alternative, and I want to kill this guy here, and I will import Pluto and run it and show just the interface. Just show that there is another alternative to like Jupyter, and that's also like a good thing, because one important thing of Pluto, and I don't know if data science, we use a lot of Jupyter, and there is some nightmare there, especially because the code is not Python. So when you have a notebook like that, it's a different thing, and it's quite difficult when you have to control the version of this notebook. On Pluto, it's much more easy, because your notebook that you're constructing is Julia. So it's actually Julia code with some comments inside the code. So that makes everything much more easy. But there is also like downsides to this. It's like a global application that you have there. If you change one thing, it will change everything. So there is also downsides to that. Don't know why it's taking a long time to, because it's also run the notebook there, and this is a little bit big. And with that, if you have any other questions, I would have to get those. And sorry for getting out of the time, Alexander. So this is like the Pluto. It's similar to Jupyter. Just that if you change one thing, if you change, for example, the variable here on the top, it will change for the whole notebook. So we can have like environments like beginning end, but it's quite good when you have to have something that's small. It's not like big notebook that you normally see with Jupyter, but you have to have like a global environment, and everything that you change in one place changing in the other. So that's quite good from some type of interaction, especially teaching. That's quite good.
I do not see new questions in the chat. People who are on the, yes, I have a hand. Anatoly, I think you can unmute yourself and ask your question.
Actually, it's not a question. It's a note that Julia's package installer is more like Conda than pip, in that it also can like pull precompiled things. So, like for example, I had a really good experience with CUDA, for example, on like WSL, and that worked out just out of the box.
Anything else?
Also, I also think you maybe undersold the composability aspect of different packages, where two packages that don't know about each other can interact in like an intuitive way. Like, for example, the like Bayesian neural ODEs.
Oh yeah, for sure. Especially because you have the same environment. Everything again when you have packages like with C++. Again, you saw the nightmare talking about vectors in C++. Every package has its own, but here everyone has the same initial. You don't see anyone like doing their own vector coding for that. So even from the coding parts, also from the environment, they're using the same environment. So you can use package, and they are much more like connected between each other. So sometimes when you use, for example, Optim, they will download a lot of different packages there, and everything. It's very easy to use them. I think that's it, right? If you have more, for sure, complement. Okay, so
yeah. So sorry. Like for example, you can write the same. You can use the same Julia code for CPU or GPU calculations for like out of memory stuff.
yeah, that's quite good. Yeah. So yeah, Pluto had some interactive things. Yeah, you can do it in Jupyter, but my Jupyter notebooks always fly when I try to do something like that. I think that's it, guys. Pluto, maybe we'll leave for another time. And thank you for the invitation, Alexander. Thank you guys for the questions. Thank you for the interaction. And if you have more questions, feel free to reach out by email, Teams, and etc. And I will happy answer those. And if you have a project here at IPAN that you can use Julia, please call me. I want to know about it.
Thank you very much. So, thank you very much, everybody, for attending. Recording will be available on the VR community portal. Thank you very much, Turner, for conducting this session for us today. Good.
Okay, thank you, guys. Have a nice day.
Have a nice day.
Thank you.
Let's
Bye-bye.
wrap up the
Thank you.
session.
Thank you.
Bye, everyone.
Bye.
Bye-bye.